as I said in this section, section 4.1, we're practicing our exponent rules. You guys here in class have had a few minutes to ponder these two sort of warm-up examples, if you will. And so what I'm going to do is I'm just going to call on some folks. We'll start with Will, take care of, for example, 5, take care of my X's. Daniel, take care of my Y's. Duncan, take care of my Z's. Please tell me what you get and what you do with it. Okay, very nice. X to the 5th on the bottom. Daniel, the Y's. Good. And then Duncan, how about the Z's? Z to the 5th, and where do you want it? Up top or? Okay, good. Z to the 5th. I don't know why I made my fraction bar so big. There we go. So we've got, as these guys said, the Y's canceled out. And the exponent rule says we can subtract, right? So another way of considering this would be to say X to the negative 5th, Z to the positive 5th. Like in algebra, that first one is more acceptable. But sometimes in your calculus class in a year or two, whenever you guys take that, sometimes it's more advantageous to be able to write it where you've got base raised to whatever the power is. So be flexible, be versatile. Either of these two, they're mathematically equivalent, and they are the simplified versions of those two fractions. And our exponent rule tells us we would subtract when the base is the same and it's a fraction, subtract those exponents when being multiplied there. So very nice. Let's go over here with Patrick. What's something on example 6 that you would cancel out? Okay, what about it? Okay, so we're going to keep the X where he's at. Perhaps I misspoke when I said cancel. What's something that you would maybe adjust or move or put together or? All right, and how so? Okay, so like we could leave our 8 down there at the bottom, and subtracting those exponents, what would you get? Well, you'd get y to the 8th up top or down at the bottom? Good, y to the 8th. Now, here's a kind of a way that I would look at this type of problem. I would look at with this negative exponent, I would say, hey, let's change his position in the fraction. Let's move him up top, and so that it would become y to the 5th times y to the 3rd up top, and then that, of course, is y to the 8th. And there we go. And again, another way of perhaps writing this out, an equivalent expression, would be to say, we got 1/8 x y to the 8th. Again, just kind of manipulating and kind of changing things around. One's not right more so than the other, but just kind of being versatile, like we said, would be the goal there. Nathan, question.
So 8 is being multiplied to y to the negative 3rd. So do we divide by y to the negative 3rd to get it to the top?
All right, so there's a couple of ways that you could think about. What to do with that y. Number one, we could express this as nothing but a product of various factors. And what I mean by a product is dividing is the same thing as multiplying by the reciprocal. So we could write this as x times y to the 5th divided by 8 is multiplying by 1/8, and dividing by y to the 3rd would be multiplying by 1 over, I said 3rd, I meant negative 3rd, multiplying by 1 over y to the negative 3rd, and then handling each of these individually. So like we said, we could even write 8 as 2 to the negative 3rd if we really wanted to get down to it. 1/8, that is. And here this would be y to the 3rd, y to the 5th, x. And then to consider, well, what would we put together? We'd put those two guys together, and we'd get y to. Does that help a little bit? So division being defined as multiplication by the reciprocal, you could technically write any fraction, as long as there's not a roadblock, a plus or minus, you could write any fraction, monomial over monomial, as a strand of factors. And then, simplify those factors as you like. Daniel? Correct. All right, and so that might be an alternate way of just thinking about the denominator. So just for a sec, pause on the numerator, and we can say this is 8 over y to the 3rd, and you can think, well, dividing by a fraction, you flip and multiply, so this could be our numerator times y to the 3rd over 8. So like where you're flipping that bottom fraction there and change to multiplication. So really one of the challenges for us in algebra is realizing that there's a lot of different ways that you could attack a problem. And you do you You work it whatever way you're feeling most comfortable working. Okay, here we go. I want to look at another couple of examples. We're going to start ratcheting up the difficulty a wee bit. Okay, there's example 7 and example 8. So you guys chew on that a little bit. Getting hot in here. And these exponent problems are helping us practice some of those basic rules that we learned about last week, I guess Friday, when we had our Kahoot. Yeah, if you're wrong Friday, you missed your Kahoot. Womp womp indeed. Who finished in the top 3 for my Kahoot? I forget who it was. Daniel and Tristan and Jackson. Okay. See, if you guys had been here, y'all could have taken them down. Almost anything raised to the 0th power is 1. 0 to 0 is undefined, but anything else is 1. And here we're assuming h doesn't equal 0, so yeah, that factor is trivial at this point. Speaking of example 7, is there anything like Alex just asked about h to the 0 is the same thing as 1, so that really is a trivial factor. I don't care about it. What would you consider doing? There's a couple of options for you. What do you want to tackle? Yeah. Very good. 9 goes into 18 twice. It goes into 27 thrice. Okay, so that's one way. And then, Nick, what would you do with that g to the negative 7? So we got 3 halves. If you didn't hear Nick's explanation, we got 3 halves. And then we got g to the negative 8 because he has subtracted. He said negative 7 minus 1. And negative 7 minus 1 is g to the negative 8. And I'm certainly fine with that. What if, like, for example, this was a delta math problem, Preston, and they said, hey, no negative exponents. What would you do to adjust to that? 1 over what? All right, and so 3 stays up top, 2 stays at the bottom, and that g to the negative 8 moves down to the bottom and becomes g to the positive 8. Right? Now, you could approach it this way. At the beginning, you could note, hey, there's a negative exponent up top. Let's move him down, and let's put him down here to where it's g to the positive 8th, right? And then you could, sorry, g to the positive 7th. I jumped the gun. And then you could consolidate those two, getting g to the positive 8 on the bottom as well. So whatever floats your boat. But good job, you guys that helped with that one. Jake, I'm going to pitch the example 8 to you to get us started. Or Houston, you got a question on 7? H to the 0 is defined as 1. And so that would be like multiply like 27 g to the negative 7th times 1. It's like, well, okay, times 1. I don't really care. That's identity property. But by definition, anything other than 0, Alex wasn't paying attention, anything other than 0 is equal to 1 when you raise it to the 0th power. Say, why is what not a
Like it's separated.
g to the negative 8? Like you could, let's see here. You could have said g to the negative 8th right there. But what you don't want to do is you don't want to subtract the exponents and move it to the bottom and keep the exponent negative in this example. So like here's what I'm meaning by that, and this is a good question. We'll handle this in green here. So suppose that I've got, we'll make something up, 2x to the a over 3x to the b. All right. Obviously, the 2 and the 3 are standalone. I'm not going to mess with them. And instead, I'm going to choose to consolidate the x's. So it becomes 2/3 times x to the what? A minus b. So it's a standalone In other words, it's off to the side, and I'm going to let the resulting exponent determine whether it should be up top or at the bottom. If a minus b is a positive number, then that x factor is going to stay up top with the 2. And if a minus b happen to be a negative number, I'm going to kick him down to the bottom to be with the 3. So two little offshoots here. Suppose that it's 2x to the 5th over 3x to the 7th, right? Then I know I'm going to leave the 2 and the 3 alone, but it's going to be 5 minus 7 is negative 2, and so x to the second is going to be on the bottom. Or if I had like 2x to the 7th over 3x to the 5th, hopefully it's obvious, again, the 2 and the 3 are going to stay where they're at, but then I'm going to have x to the second up top because 7 minus 5 is 2. That's not negative, so he's just going to stay where he's at. And then, of course, an alternate way of doing this, fellas, watch this now. An alternate way of doing this is just to slope play it and say this is 2x, x, 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 3x, x, 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 and then we scratch out 5 and 5, and where are those 2 remaining? They're remaining in the bottom. You can kind of look at it that way as well. And then similarly with the 7 up top and the 5 at the bottom, you cancel those out. Okay. So we talked about h to the 0 equals 1. That was good. Question from Houston. We talked with Nick about what's moving up and down and what we do with it. Duncan, you had a hand up?
So like any case of like an equation where you have the both variables with like sign, like say like you have like x to the 8th on one side and y to the 4th on the other, would it be useful to simplify the like square root here?
Yeah, so that's a good question. Like, and one of the things that we're going to do in kind of a look at coming attractions in section 4.5 is we're going to talk about equations of higher degree. Like right now, y'all are comfortable solving linear equations and quadratic equations, should be very comfortable solving those types of equations. Degree 1 has 1 solution, degree 2 has 2 solutions, degree 3 even, I could give you a degree 3 equation and say, hey, like x to the 3rd minus 9x equals 0. And like you guys could solve that. Now you would need to use factoring in the ZPP, but you'd take out an x squared minus 9. And what would your 3 answers be? Just real quick, what are they? 0 plus or minus 3. And those would be our 3 answers. So like even with degree 3 equations, if you can factor it, you can solve it. Eventually what we're going to do is we're going to get to some of those higher degree equations. Okay. Let's see here. Well, even that one's a degree 3, but it doesn't factor. And you'll talk about, well, what are some techniques that we could use to solve those types of equations? And so like Duncan's question, one of the techniques that you might employ, let me go back here to the notes for today. One of the techniques you might employ, if you had something like x to the 4th equals x to the 2nd, you might be tempted to say, well, I'll just take the square root of both of those. But we got to be careful. We got to remember things like absolute value and remember plus or minus. So we'll get there eventually, but good question nonetheless. Jake, I think I was going to prime you for something here. There's lots to do. You tell me one thing to do here, for example, A. All right, beautiful. So he's going to take out a common factor. We'll do this one in green here. Take out a common factor of 4, goes into 25 times. Very nice. Noah, what's something else you'd like to tackle? Okay, so -2 take away 8 would be -10. So we're going to have x to the 10th on the bottom, perhaps. Another way of looking at that would be to say, hey, let me move that negative exponent down to the bottom and make it a positive. Okay, so we could have x to the 10th down at the bottom. I'm down with that. Okay. Nicholas, what about you? What's something else you might strive to do here? Maybe something in that second fraction.
Second fraction has negative.
Okay, good. So 5 goes into itself once. 5 goes into 15 thrice. Okay, so we've got that -1 up top and the 3 on the bottom. And then, Braden, how about the y's on that second fraction? What could you do?
The y
Beautiful. We move him up to the top, y to the 9th, y to the 1st. We consolidate that to y to the 10th. Now, let's see where everything kind of falls out. Up to the top, we've got y to the 5th. We got a -1. We got x to the 6th. And we got another y. This one's to the 10th. So I'm just going across the top and across the bottom now. What about on the bottom? We got a 5 and a 3, so that's 15. X to the 10th. Okay. So visually, I'm just rolling across. I got 5 and a 3. I got x to the 10th. That guy got moved. So I guess I should have scratched him out once he moved, just so I didn't think about him. All right. And so now, Jan, help me. Like I've got this down to a monomial on top of a monomial. So it's like one of those previous examples. Help me consolidate some things. What would you put together?
It's the x's.
Okay, good. So how many x's will be left and where will they be left? Good. So I got 15x to the 4th on bottom. And then Tristan, how about the top? Y to the what? Y to the what? Attaboy. Good. So y to the 15th. And that negative resides up there still since it was a coefficient. Now, hey, one thing to kind of keep straight, you guys will get a chance to practice this on the devil's math, is that and listen to me on this, the coefficient and the exponent are different things. So a negative coefficient does not play by the same rules that a negative exponent does. Negative exponent, we're thinking like move his position in the fraction. Negative coefficient is just a number. It's just like when I was talking with Nick's question a minute ago, it would just be like that 2 or that 3 or whatever. It's just a number. It's just chilling there out front. It does not affect anything with regards to the exponent. Cool. Multiply the two what? For sure. Okay, so let me change color here. Like what you're saying is we got a y to the 5th, we got a -1, we got an x to the 6th, and we got a y to the 10th. That's precisely what we have right there. We got a y to the 5th, check. We got a -1, check. We got an x to the 6th, check. And we got a y to the 10th, check. And then I forget who did it for me, but somebody just put these two y factors together, and we got y to the 15th. Tristan did, I think, as a matter of fact, because you had the exponents. Good question there. And look, there's a lot of moving parts, and this is not the big boy example yet. Okay, there's a lot of moving parts that you can easily get, like stuff can slip through the cracks. So I highly recommend take your time, show your steps. Don't try and do too much at once. Okay, take your time, show your steps. Don't try and do too much at once. Okay, yeah, wearing your big boy pants. Oi. All right, there we go. Wayne Suerte.
Good luck, right?
See. No, I mean, this is just a beefed up homework problem. And again, man, I'm compartmentalize the heck out of this. Definitely. Just deal with the first fraction, deal with the second fraction, deal with the third fraction, then put them together. And what I'll do is I'm gonna put some pressure on you. I'm gonna put you on the clock. You got 3 minutes. We'll give you 3 minutes. Somebody yesterday was like, it would take me 3 minutes to write it down. Alex, I missed your question. What was it? I don't know. You tell me. 2 more minutes. Uh-oh. Jan, does this look like yours?
Yes. I check on my name.
Yeah. All right, about 30 more seconds. 3 minutes is an unreasonably short amount of time, I know. But like I said, I'm putting pressure on. Ow.
It's usually divided and split and multiply, so like I'm kind of intention saying let's split this and multiply. You know what I'm saying?
All right. Simon, as a class, we might not be finished, but I'm gonna start individually kind of picking it apart. Actually, you know what? Scratch that, Simon. You're off the hook for right now. What I did with this one yesterday was I silently started working it out. And then you can, if you want to look up, you can kind of see and check, or if you're still kind of grinding, we'll do it that way. Okay, I think I like that. So, man, there's like bless you, there's like 20 of us in here, and very likely we probably picked 5 or 6 different ways to attack this one. But at least what occurred to me was for the first fraction, I just moved the 2 guys from the bottom up at the top, consolidate. That should be easy enough. Everybody comfy with that? Okay. The reason I can move is that there were no roadblocks in that one, just FYI. The middle one, be careful. Like my personal preference was to tackle this squared at the end. Yesterday, I saw a lot of students that wanted to go ahead and square everything. Just be cautious because what you would be squaring is the numerator, which is being squared already, so it'd be raised to the 4th. And then there's 3 factors on the bottom, 12, a to the 9th, and b to the negative 3rd that will also need to be squared. So I don't like applying that big squared initially. I would put it off until the end. And then also what I liked about that was when we did the little square on the inside, 6 squared is 36. 36 simplified down with the 12, which made that big squaring job a lot easier. We consolidated the A's, moved the B's up top. Everybody get B to the 12th squared is B to the 24th. Like when you raise a power of a power, what do you do with those exponents? You multiply them, right? So B to the 12 to the 2 becomes B to the 24. And when B to the 24 paired up with B to the 3rd, B to the 3rd came up. So we added and got B to the 27th there. And then when we squared 27, we got the B to the 54. Because again, power of a power, you multiply and 27 times 2 is 54. What happened with the 3rd fraction was a division problem. So after everything got settled, then I flipped it. Be careful about that. Don't flip early. Settle your affairs and then flip it. Okay. Nathan, question?
Yeah, I got exactly that, except I just got a 4.712.
Hey, I've made a mistake. Actually, I did it twice yesterday, so I didn't do it this time because I remembered. But like the 9 over the 27 left a 3 down here, and yesterday I saw the 4 and I started writing my answer up, and then I got over here. I was like, oh snap, there's a 3 left over.
I might have done that.
So look, that was at least it happened to me yesterday twice. Tristan.
I got the 3 option denominator. Well, like in the very bottom.
How we got these 3 denominators?
Yeah, like how you got the 3 in the denominator.
Oh, how this came about.
Yes.
First, okay. So let's start. So if you didn't hear the question was where did this 3 come from? All right, and it starts up here. We've got this cube is being applied to all 3 of those. So it's 3 cubed, a to the 5th cubed, and b to the negative 4th cubed, which we know is 27 a to the 15th over b to the 12th.
Oh wait, I think that's where. I think I did 3 squared instead of.
Oh, snap. Tristan, you good so far with the green? All right, and then because this was a division problem, we had to flip this after the affair was settled. And Daniel, I know you had it up as well. We're going to flip this fraction after the dust has settled with my cubing and my taking care of the b to the negative 4th. So now that that's settled, we flip it, and it becomes this fraction right down there. And then because we had a 9 from this middle fraction, that 9 over 27, 9 from the middle fraction, 27 from the 3rd fraction. We had some other stuff going on there. Going on there. It's sort of like we just had a big old cancel party, and we just canceled a whole bunch of stuff. And what did we cancel out with regards to the 9 and the 27? We said 9 goes into itself once, and it goes into 27 3 times. So that's where that 3 came from. Daniel? All right. Okay, good. I think I can do this down here with our explanation. So let me go to blue here and just highlight our A factors. Okay. Now, if I'm tallying things up, maybe it would be smart to tally up what's at the bottom first. Like in my brain, I was just like, all right, I'll kill off 12 of these guys if there's only 2 left. And then 2 and 15 makes 17. But perhaps 14 and 15, it'd be better to look at it. 14 and 15 is a to the, what is that, 29? 29. And up here at the top, we got a to the 12th. And so we would subtract those 2. 12, take away 29, it's a to the negative 17th, or 1 over a to the positive 17th. Just talking about the a's there. That answer what you're looking for? We had 12 a's up top from the first fraction, 14 a's on the bottom from the middle fraction, and then 15 a's on the bottom from the third fraction. And so consolidating those three blues, got a 17 on the bottom.
Remember the addition part.
Yeah, what to do with regards to division. We're going to take whatever fraction we're dividing by. I don't care if it's the second fraction or the third fraction. If you're dividing by that fraction, you flip it and change to multiplication. So take that blue fraction right there and just put everything. So 27a to the 15th on bottom and b to the 12th on top. Change to multiplication, and now we're back to normal.
Do you think it'd be like best if you just like for us if you like made just one big fraction and then just simplified it out?
Yeah, so that's kind of the approach I took down here in green. However, only do that once Nick's question is taken care of, once you've changed it to multiplication, and once you've consolidated sort of in-house as best you can. Like, for example, I wouldn't want to write one big, this is personal preference again, and I'll change to black here so that we can kind of distinguish what we're talking about. But like, I wouldn't want to just take all of this jibber jabber and write it as one big fat fraction, a to the 7, b to the 10, 6 squared squared, a squared squared, b to the 12 to the, so b to the 48, and then like you'd flip this at b to the 12, 27, a to, I wouldn't want to really do this, I don't think, just because for my money, that seems like that would be a lot. A to the 18th, b to the negative 6th, 4, a to the negative 5th, b to the negative 2nd, and then start dealing. Like you could, like I said, there's 20 of us in here. I bet there's 5 different ways of working this problem. To me, that looks like that could be a bit confusing if I'm not careful. All right. So that's, we have now practiced some of our advanced exponent rules, as well as some of our more basic exponent rules. Okay. Don't forget, there was another exponent rule we called the phrase that pays. What was that phrase that pays? Power over root. That was in a way of changing from exponent form to radical form and back and forth. Now what we're going to do is we're going to take a little bit of a break from the difficulties of exponents, and we're going to talk about polynomials. Okay. Talk about polynomials. And the second half of tonight's homework, by the way, tonight's homework is on Delta Math. I posted it yesterday. You might have already seen some of it. They are sections of 2 problems each. Okay. There's sections of 2 problems each. Let's go Delta Math. I'll show you real quick while I'm thinking about it. Seventh period. Oh, look at that. Some of y'all already got it done. Good deal. Yeah, each of these problems there's 2 per section. So, I mean, it shouldn't take a super long amount of time. Look like 19 minutes, 30 minutes, 30 minutes, 59, 18. So like it's not going to take you a super long amount of time, right? But the second half, the problems that are over here on the right, that's what we're about to get into with regards to the polynomials. Okay. So, polynomials, we got to understand like terms. What like terms means, that phrase means that you got the same variable, raised the same exponent. Okay. So for this first example, as you're jotting this down, you got quadratic term, you got a constant term, quadratic linear constant, quadratic linear constant. So it looks like we're going to have, our answer is probably going to be 3 terms. Okay. Now, Noah, what property would probably get the ball rolling for us here on this example? Yeah, very good. Our distributive property. I'm gonna dump that -5 into that middle parentheses right there. Alex, you good? And so if I multiply that out, I don't know, Patrick, you want to do that for us? hold on. My pencil's acting crazy. Minus 10x and then plus 5. Why now? All right. And we really weren't doing anything with these other ones. Just kind of lining them up. Okay. Jake, consolidate all my quadratics. Let's get Cole to consolidate all my linears. And Samuel, consolidate all my constants for me, please. What
should be.
Okay, so good question. This is a +1. And so distributing a +1 doesn't change any of these three terms. If it had been a -1, absolutely distribute the -1. If this had been like +7, we distribute the 7, you know, whatever's out there. If it's going to affect or change those three terms, I would definitely use the distributive property there as well. But since it's just a +1, no sweat. Okay, so who's got my quadratics? Is that Gustav? What you got? All right, so -12x squared. How'd you get that? Or is that? I think maybe -8.
Yeah.
-8x squared. All right, and then who was it that Cole? You got my linears?
Yeah.
All right, so what are those? How so? Degree 1. So you got a -10x and a -8x.
The -8.
-18x. And then Samuel, you got your constants? Gotcha. Okay, that's what Cole was talking about. Plus 16. Okay, I can get down with that. So look at that. We've got those three terms constitute our answer. And that's a pretty easy first example. You could, I don't really care. At this point, we're just practicing consolidating. Now here's where I want to throw a little curveball your way. Okay, let's make this a little bit more difficult. The ACT is not going to come out, for instance, and say, hey guys, here are these three, you know, put them together. What they would do is they would say, let A equal this, and B equal that, and C equal this. And oh, by the way, now I want you to tell me, what's the value of A minus 5B plus C? Same exact problem. They're just framing it a little bit differently. We worked this yesterday in second period, and what they might do is they might say, I want to test to see whether or not these kids can add and subtract polynomials, but they're not going to just come out and be like, hey, add and subtract these polynomials. They're going to disguise it behind the guise of some extra variables. You understand what I'm saying? So they're literally just saying, hey, call this A, call this B, call this C, and we're going to do A minus 5B plus C. Same exact problem, you get the same exact answer. It's just an added level or layer of complexity there. So be on the lookout for that. That's a little ACT kind of strategy where they all of a sudden throw A, B, and C in there, and you lose your brain. Okay. Now, here's your next example. Instead of adding and subtracting, I wonder if you are good at multipliers. Okay, Nicholas, that's a binomial times a trinomial. Before we simplify, how many terms will that be resulting in? How'd you get 9? Good. How'd you get 6?
Because you have three different ones for the first and the binomial and then three for the second one.
All right. So what we're going to do, this is like a FOIL problem, just a beefed up FOIL problem. We're going to multiply everything in the first times everything in the second. Okay. Nick, do those 3 black multiplications. Noah, do those 3 red multiplications. We'll play a little checkers here. Sorry, Milano, no, Mihalko, excuse me. Negative what? Coefficient.
Oh.
X times -7x. I need. I need to hear the word 7 come out of your mouth sometime during this answer.
7x squared.
What kind of 7x squared?
I thought I said negative.
You just said negative x squared. You meant negative 7x squared. Okay, good. We're on the same page now. Keep on going. 2x. Good, 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 good. All right. And then Noah, you got the red ones? And Jan, what's weird about how I wrote that up? There you go. That's just best practice, I think, right? Because you're looking to combo. Now, Nicholas Hedrick had given me, he said, hey, it's a buy times a try. A buy times a try is going to yield how many terms? 6 terms. And then we're going to consolidate as we can. And by consolidating, we're going to get it down to how many terms? We got it down to 4 terms. Okay. So this tests to see whether or not you're good at using the distributive property. It's very FOIL-ish. Okay. FOIL was you're multiplying a buy times a buy. 2 times 2 generates 4 terms before simplifying. FOIL. This one's a buy times a try. What if we multiplied Houston? What if we did a try times a try? How many terms before simplifying? Good. You'd have 9 terms before you simplify. Right? Now, oh, go ahead, Danny.
When doing these types of, we're always gonna have one, number that doesn't, group together with anything on like that side.
Good question. No, the answer would be no. It depends from problem to problem. Like sometimes you'll get problems where you, like a FOIL problem you could have where you multiply 2 times 2 and then all 4 of them and none of them consolidate. And then there's other times where you might multiply, like we've seen FOIL problems where you multiply a buy times a buy and you only get 2 resulting terms. So it just depends from problem to problem.
So, seeing that like there's x to the third minus 4x to the second. With that, so, when you think about like quadratics, the power kind of determines the amount of solution.
Mhm.
Would that mean that there's 3 solutions or like?
If this were an equation, if at the beginning we had this set equal to 0, then you're absolutely right. We would have 1, 2, 3 solutions. And in fact, one of those solutions would be -3, and the other 2 solutions would come from this quadratic, and this quadratic doesn't factor, so you'd be forced to use the quadratic formula. You know what I'm saying? If it were an equation. Now, it's not an equation, so if ifs and buts were candies and nuts, every day would be a party. Simon, what in tarnation are you and Alex doing? Y'all multitasking son of a gun. All right, here's what I'd like to do. Oh, go ahead, Nick.
Here's what I would do that third, 2x, but yeah, you multiply the 3, I see that, but the x.
All right, so as far as x times 2 gave us 2x, and then 3 times -7x gave us -21x, and then we put these two together, positive 2x and -21x made -19x. Cool.
6 solution, because x is 6, and
Okay, so
He said.
I don't want to say this. This is not meant to be hurtful. A lot of wrong things you just said. So let's clean this up. Smiley, don't be staring daggers at it. Okay, so there's no, we're not solutions anything. We're not solving anything. When we multiply a buy times a try, the resulting product is going to have 1, 2, 3, 4, 5, 6 terms. And that's where we were talking 2 times 3 would be 6. If it were an equation like Duncan was asking, if this had been set equal to 0, for instance, the degree of the polynomial would tell you the number of solutions. So you wouldn't figure out the number of solutions to said equation, if it were an equation, until you lined it up as a polynomial and you identified the highest exponent. And that would tell you, oh, it's degree 3, there's going to be 3 solutions. Okay. Now, here's what I'd like to do. You guys are good note takers, right? Y'all jotted the answer to, you know what the answer to this problem is, yes? Okay, I'm about to erase it. Read me off the answer. All right, pretend with me that you have not worked this problem yet. You have not worked this problem yet. And the ACT or our first semester exam or whatever, like high stakes test you're sitting for says, hey, here's this equation, solve for K. Tell me what K equals. Now, you're not allowed to tell me that it's, what was it again? Was it 8 or -8? -4. Yeah, you're not allowed to tell me it's -4. You don't know that. Pretend like you don't know that. What would you do? We see this problem on an upcoming problem set. And that's exactly what you're supposed to do. I feel like I've primed the pump, though, and you already knew to like, quote, foil that out. Right? But in the heat of battle or in a couple months when you're not thinking about this straight, you might look at this and be like, well, I guess he told me to solve for K, so I'll just get K by itself. And you start moving everything over to the other side and getting confused. What I submit to you is that we can assess what type of term this is. What type of term is that? Quadratic. The word is quadratic. Degree 2, quadratic. What would yield? Which multiplications would yield a quadratic term over on the left? Don't give me the whole kit caboodle. Just tell me which multiplications would yield a quadratic term. Jan, I see a hand up.
B times x squared and x times negative f.
All right. Those two are the only ones I would have to concern myself with. This is an easy problem. Now, I don't have to sit there and do 1, 2, 3, 4, 5, 6 like we were talking about. I could just cherry pick out which ones pertain to that term that I'm trying to figure the coefficient of. Right? And so now I got 3x squared minus 7x squared equals kx squared. And I could very easily say, well, what's 3 minus 7? Negative 4x squared. And therefore, negative 4 must equal k. All right? Now, you want me to add an extra layer of complexity? Are you ready for this? Okay, watch. Now we're going to, I'll change it to green. Now we're going to add an extra layer of complexity. We're going to say 2x cubed minus 38x plus 12. Now I can't do my same little trick, right? I can't do my same little trick because the left-hand side and the right-hand side don't necessarily equal each other as we did earlier. Okay, so my point is we have to be cautious. We have to be careful when the left-hand side and the right-hand side might not necessarily be set up prefab good to go for you. Tristan?
How would you be able to tell if this was just like a problem if they were set up?
I would definitely work out this left-hand side.
Just no matter what.
Correct.
Correct. You say if that, you just say that's false.
No, let's see here. What would we do here? Y'all read me off, Noah. Read me off what it was again. Our original answer. The one I told y'all to make sure you had written down.
X to the third minus 4x squared.
6. Let's see here. What would I do? What would I do? Maybe there would need to be like a 2 set up out front. Something like that, where maybe like at the beginning, if you divided by 2, and then divide, and you'd wind up canceling out the problematic factor and being back to what you started with. But just kind of being on our toes for these, it's not always just a simple does he know how to foil type problem. Benny Heaney, what do you got for me? Thank you, brother. All right, so that's our lesson for today. And as I said, you guys have an opportunity now to work. We've got about 6 minutes to work on some delta math. Yes. Certainly. That's what I'm going to do for the next several minutes. All right, let's see here. Yeah, this is a FOIL problem. And it's got fractions in it. So just kind of being careful about the fractions is what I recommend. So like first times first would be 1/30 x squared. The outer two, the fives are going to cancel, so you would have 1/4 x. The inner two is just going to be 1/6 x. And then the last times the last is going to be plus 5/4. And consolidating these two is going to require you to get LCD. All right, if you're watching at home, that's the end of the lesson. So thank you very much.